my blockhead has this this plugin system, which people sometimes ask about, and I'll link them to the repository, and then I'll say I'll link it to them with the caveat that this is all going to change soon, so you shouldn't spend time making blockhead plugins yet. And I'm finally at the point where, so this plugin system, the way that I've written it, it's like a really good first attempt, I think. It's served me really well up till now, but it's time to redo it for various different reasons. One of the main ones is it's like the main like major blocker towards the instrument system and MIDI support. MIDI support in Blockhead, there's something that like people ask about, and usually it's people who have not actually used Blockhead yet, so they don't realize what it is they're asking, because and they never explain obviously like what it is exactly that they mean by MIDI support, because then the MIDI signal has to do something. Like what is it that you want this theoretical MIDI signal to actually do? Because there's nothing in Blockhead right now to trigger, because like when you press a key on your keyboard, Blockhead isn't written in like the traditional way that a DAW is written. So the way that a DAW is usually written is sorry, I just got out of the shower and my glasses have all steamed up. So I'm just going to wipe them down and then continue talking. Let's just wipe off my forehead with my t-shirt. The way that a DAW is typically designed is it's all based around MIDI, and so the idea is you have some kind of environment and you add these like machines to the environment, and the machines are all communicating with each other via these like virtual wires, which are either like going to be MIDI signals or some kind of communications protocol, and then audio signals. So this is like how a DAW is typically like written. Blockhead, that just doesn't have anything to do with like the way that Blockhead is architected. In Blockhead things, it's more like you have a canvas and you're painting like pixels on a canvas. Like you're arranging sound on a timeline, and it's to a certain extent you have these like objects that exist on the workspace that you can interact with, because you're like painting, but you're painting in a non-destructive way. So if you paint like some kind of sound, if you imagine this is a sound on the timeline, you can then like click it and drag it around, because it's a non-destructive sort of painting environment. But the point is that there's no like objects that exist in the environment that you can trigger via MIDI. That's just not a thing in Blockhead. That's not the way things are. Like the same way as like in a painting application, you're painting pixels on a canvas here. What would it mean? So the question is, does MS Paint have MIDI support? What would that even mean? Like, what do you want the MIDI signal to actually do? So that's the situation at the moment with this plugin format, where the plugins are basically, how to describe the plugins? They're basically a way of like representing, just to continue the painting analogy, like representing a sequence of pixels, a non-destructive sequence of pixels on a timeline. That's what like an instance of a plugin is in Blockhead. But it doesn't have to be that way. We can support MIDI, and it wouldn't even be that hard. Basically, I just need to change the plugin system so that Hold on, let me do more explaining how the plugins work. So you have a block in Blockhead, which is it could be an audio processor or an audio generator. Maybe it's generating audio. And as the playhead moves from left to right across this block, we're processing the block a little bit at a time, little bit at a time. So we process that bit, then we process that bit, then we process that bit, then we process that bit. And the block is backed by a plugin. And the block has envelope data associated with it. That's just one example of the kind of data that it has. So there might be an envelope that exists in memory, controlling the pitch or something like that. And the way that the plugin system works is we're processing this block a little bit at a time. This is going to be a very simplified explanation anyway of how it works. And every time we process it, this envelope data, we just pass a pointer in to the entire envelope data every time we process it. So we process this bit, we just pass a pointer into the envelope data. And this bit, then this bit, we're just passing a pointer in. So every little bit of the block that you're rendering, every little chunk of DSP that you're doing, you're just getting a pointer to all of the data that is associated with that block, all of the envelopes, all of the slider data, all of the options. You just get a pointer to a big blob of memory that you can read from. Which again that's not the way that things typically work in a DAW, right? So in a DAW, let's say even if you did have a piece of sound represented as a block, like you do in Blockhead, the way that this envelope data would be transferred wouldn't be the same way. It would be basically transferred a little bit at a time. So it would be converted into a series of MIDI events. So it would generate mini events like this, at regular intervals of what the value of this envelope is at any given time. And then and then it just sends these sequentially over time. It will send these MIDI events to whatever abstraction is doing the DSP. Right. So the way that I do think that I'm going to invent some terminology here. Actually, I'm going to borrow some terminology from the world of OpenGL shader processing. I'm going to call the way that I do things is let's call this uniform data, where you just have some data associated with the block, and each part of the block you process, you're just passing in a pointer to the entire block of memory. And the way that this traditional way of doing things, where you generate a sequence of MIDI events, essentially. Doesn't have to be MIDI, but you generate a sequence of events, and then the plugin would be responsible for interpolating between these different values. That's the way that things typically work. I'll call that, again, to borrow from shader terminology, varying. So the way that Blockhead works at the moment is uniform, and this traditional way of doing it I'm going to call varying, just because it's an analogy to OpenGL shader programming. I think some people, if you're watching this, if you're familiar with OpenGL, maybe this puts things into, maybe this is a nice analogy to try to explain. So and shaders obviously support both uniform and varying type of data, and that's what I want to do with Blink. I just want to update this plugin format. There's a lot of things I want to do with Blink, but one of the main things is I want to update the format to accept both uniform, as it currently does now, and also varying data. Once I have that, these blocks can be used both in the way that they're being used now, where they're sort of a representation of a non-destructive edit of a piece of sound or modulation that exists on a timeline, kind of like a bunch of pixels on a canvas. But they would also be able to be used more like an instrument is used in a typical digital audio workstation, where you basically add these machines or these objects, and then you can trigger them via MIDI. Like once I have this support for varying data, then I can just like pass them MIDI signals and have the plugin. I can run these blocks in a special mode where they're basically like running continuously, like a VST plugin or something like that would do in a normal DAW. And I could send the modulation data as varying like data points. Yeah, I skipped over a whole bunch of stuff about how the way that I like deal with in uniform mode, which is how the plugins currently work. I have this whole system in Blockhead for eliminating. Let's say you like modify one of these envelope points. You're like dragging things around or moving blocks around in the workspace. Every time you change anything in Blockhead, I basically create a copy. Semantically, I create a copy of the entire project, which sounds really expensive, but it's really cheap because of this magic thing, the magic of immutable data structures. But you can think of it as I'm creating a brand new copy of the entire workspace. So every time you change something, I create a copy of the entire workspace with that change. And then Blockhead will keep the old version of the project in memory for a little bit and crossfade it out while crossfading in the new version of the project. Another thing that happens is in Blockhead is when you're playing back and then you hit a looping point and Blockhead loops back to a previous point in the timeline. Blockhead will like continue playing the song back at this point while fading out, and then begin playing back from this point while fading in. So it's another place where I try to eliminate clicks and pops during looping points, because sometimes you'll just like you'll hit a loop point and it'll be, you know, you have a continuous waveform and you'll hit a loop point and it stops there, and so suddenly it's doing that, which generates a clicking artifact. So there's two like that's the two like situations where I'm like fading out an old version of data and then fading in a new version. So effectively what that means is for each of these plugins, for each instance of these plugins, I actually generate 4 of them. I need 4 at minimum, because the data could be changing, which would trigger Blockhead to like state transition from the old version to the new version, and you might hit a loop point at exactly the same time. So in total, I need 4 versions of the block of every block, or of every instance of a plugin, and those 4 versions are called units. And it sounds really expensive, like, or wasteful, having like 4 versions of every plugin, but you have to remember these are not like VSTs or some kind of typical plugin format that we're talking about. It's not literally like having 4 instances of a VST for every one instance that you actually need. These are like very lightweight entities that exist in this plugin format. So it's very cheap to do this, and most of the time there's only one unit actually processing at any one time. Okay, so that was a digression from what I really wanted to talk about, was just what I'm changing with this plugin format. I probably shouldn't have gone on that digression because it's irrelevant, but there's something, I think that's something that might be a bit confusing just from my description of how the plugin format works. What was I? Okay, so yeah, this is the reason I shouldn't have gone on that digression, is I've completely lost my chain of thought. So yeah, I'm gonna make it so that these plugins can be put into a special mode where they're kind of like VST. They sort of run sort of like VST plugins where they're running continuously and can receive this varying MIDI data and respond appropriately in some way by interpolating the data, just like a normal VST would do. Yes. So okay, the other thing I want to do with the plugin format is the way things are architected at the moment. Again, I don't have any regrets about doing it like this. It's a pretty good first attempt, to be honest. But we have the host and we have the plugins. Each plugin, it has like an init function that the host will call and at startup when it's scanning the plugins. And what init will do is it will set up all of the parameters that the plugin supports, and it will basically store them in its data sections. So it will store them all in a database. So for example, it might have an amp parameter, and it'll have all of the information related to that amp parameter there. And it'll have a pitch parameter maybe. And it has all of the information related to that pitch parameter there. So when the plugin starts up, it'll collect all of this information and just store it in its own data section. And then might have another plugin that's doing exactly the same thing. And so these two plugins have the same amp and pitch parameter. And maybe the amp and the pitch parameter is exactly the same. Maybe it's just defaulted. Because which is fine, because one of the deliberate things about Blink is you can have parameters that, like, the host will recognize that this parameter and this parameter has the same ID, and this parameter and this parameter have the same ID, and so it'll group them together and like semantically associate them together, so that the user can do all sorts of weird things where they can like manipulate the pitch of two plugins at the same time, even though the plugins came from potentially different developers. They both support the same pitch parameter, and so they can manipulate them together. So from the host perspective, the pitch is like this ethereal sort of concept that exists, rather than being a specific parameter. But each plugin has all of the information that it needs, all of the configuration of each parameter stored inside of itself. And a lot of the time, this is just default. So where's this information coming from? I have like inside the Blink GitHub repository here, I have this plugin, this directory called plugin, which is basically, okay, right. So don't click that. In include, this is a C API for implementing the plugins. So if you just implement the C API in whatever way you want, you have a valid Blink plugin. If you implement this API and compile a DLL, if the API is implemented correctly, then it's a Blink plugin. Then I also have this directory called plugin, which is basically a C++ library that is it's written to help in writing plugins. So all of the current plugins in Blockhead are all implemented using this C++ library. And again, it was pretty good first attempt at this stuff. A lot of the stuff is going to be, a lot of this stuff is fine in here, but most of this stuff is not going to be rewritten. But like all of the interesting stuff is not going to be rewritten. What I'm going to be rewriting is the structure of things. So I'm going to change the structure of this this API a little bit. Most of this C API is fine, and then the structure of this this companion C++ library for helping to write the plugins is going to change. A lot of the work that plugins currently have to do is going to be offloaded to the host instead. So that writing plugins is going to get a lot simpler because there's less stuff that we're going to have to do. But also the whole like architecture of things is going to change as well. So what I'm planning to do at the moment is well, I'll continue explaining how things work at the moment. Is what I was talking about, each of these parameters has a bunch of information about the parameter. Like it's a configuration and settings of the parameter, like min and max values, and how to convert values to strings and back again, and default values, and the name of the parameter even, and descriptions, stuff like that. It's quite a lot of stuff that each parameter can potentially have. And so let's say we have two plugins here. They both have an amp, and the amp parameters just the default settings. I'm not changing anything about the amp parameter. So the way that works is it just calls into this C++ companion library that I have in here. And I have a bunch of code in here for just generating the defaults for each of these parameters, because these are like standard parameters that that Blockhead supposedly knows about. Like they're the standard, and temporarily they're all just sort of listed at the top of the header file, these standard parameters. So you can create plugins with whatever parameters you want. If you think up a new type of parameter, you can just add it. But you can also use these standard parameters, which is supposed to sort of simplify things. And the only way that they simplify things at the moment is the fact that the companion library has a bunch of code, basically, in this directory for generating default data for these parameters. So the way that we get like the default amplitude envelope or the default amplitude slider is just by just calling into the companion library. And getting it. And so once we generate these parameters, we're storing them in the data section of the plugin. And so a lot of the time we're just storing duplicate data, actually, which is not a terrible thing because they don't take up that much room. I'm not that concerned about like the memory that they're taking up or anything, because these are pretty tiny data structures at the end of the day. But it is kind of stupid, isn't it? And it doesn't. Going forward, this is not going to make much sense. And also, one of the reasons that's not going to make sense going forward is I would like to make it much simpler to implement these plugins. One of the ways that I want to make it simpler is, instead of collecting all of this information about the parameter, if it's just default, if you just want the default version of that parameter, and we already have this like concept of standard parameters, right? These standard parameters that Blockhead supposedly knows about, which it doesn't really at the moment. But let's say you want to add one of these standard parameters to your plugin, and you just want the default settings. You don't want to change anything about it. Then you should be able to just register that parameter by its ID. It has an ID like this, and just get the defaults automatically without having to like go off to this companion library and generate all of the data and then store it anywhere. I should just be able to say to the host, hey, I want the default version of this parameter, the default version of this parameter, and the host should know what the default settings of those parameters are. At the moment, Blockhead doesn't, all of the information about parameters always comes from the plugins. It doesn't know anything about the defaults. So, okay. So what I want to do, so the way that, okay, again, let's start again. So what happens now at the moment between the host and the plugins? Pluggy. The host will scan for plugins. It's just scanning for DLLs basically. In the DLLs in the Blink directory, and it'll encounter a plugin and it'll call the init function of the plugin. And this will go into the plugin, and the plugin will generate all of its parameters, and then it'll store it in its data section, in its own like database. Then the host will call a function. I can't remember the exact off the top of my head, but it's something like get num parameters, something like that. That will return a value, and then for each of those, it will in a loop. It will get information about each of those parameters. So this will return something like 5. So 5 times it will just pass an index and get information about. There's something like get param info, something like that. In the plugin, so it'll just get information. So every time it's getting the parameter information, what we're doing, we're just going here into this database inside the plugin, and recalling this information that we got at startup, and then that information comes out back to the host, and the host does whatever with it. The host actually puts it into this like Blink agnostic database of parameter targets, basically. The reason it's Blink agnostic is I've designed it in a sort of forward-thinking way that will should work when it comes to like adding VST support and that kind of thing. Like the potential targets for a manipulator, for example, could be either a Blink plugin or something else like a VST plugin or something like that. A specific parameter on a VST plugin, something like that. So the information about these parameters is stored in a Blink agnostic way inside the host. So instead of doing it like that, what I'm going to do is I'm going to call init during startup when we call the when we're collecting all of the plugin information. I'm going to call it init with a bunch of, I guess it's just going to be a bunch of callbacks, like a bunch of function pointers that the plugin will use to communicate back to the host. So I have a bunch of function pointers. So the init function of the plugin, instead of like having its own like database of parameter, the only reason it has this database is because the host, right after calling init, is going to like query it for information about the parameters. And then there's no reason for it to really, well, there is a reason for it to exist. Because during the DSP, we also need that information. But anyway, that's not that important. So during the init of the plugin, what we're going to do is just call these function pointers that the host is going to pass in. So it's going to be something like add parameter, and you could pass it, for example, so this puts an host add parameter. You could pass it like the ID of like the AMP standard parameter, for example, Um, and that will just the host will have its own database of all of the Blink plugins that exist across um, all the plugins. So it will have its database of all of the Blink parameters. I meant to say across all of the plugins, and so it will expose this interface to the plugin via a bunch of function pointers, and the plugin just say, I have this I want to add the default amp parameter for this plugin, and the host would be like, okay, I'll just create it for you and add it to its own database. And then alternatively, we can do like host add custom parameter, something like that. And again, you could add the ID of the amp, but then you could say, I also want to customize the parameter in some way. And you could do that as well. And again, it will be added to the host's like database of Blink parameters. And then once the host has its database of Blink parameters, then it can convert it into this this Blink agnostic format that it needs for interacting with the manipulator system and all that stuff. Yes, this makes sense. And so there's no need in the plugin anymore for having its plugin database. It's all just going to exist on the host. And then there'll be an interface for querying, because the plugins need to actually know things about those parameters in order to do things with them. But the host will just expose an interface to query it. The crazy thing about that, actually, just thinking about that now, is I could technically make it so that plugins can access the parameters of other plugins in memory. And get information about the other plugins. I don't know if that's going to be useful, but that's an interesting upshot of this new design. It's a much cleaner design as well. It's the way that things worked before is just kind of messy. It just didn't really make sense. The fact that we had like duplicates of all of the parameters in each individual plugin, it's just a messy way of doing things, and this will be a much better, and it'll just simplify plugin creation in one way. There's a bunch of other things that I want to do that will also simplify the process of creating plugins, because at the moment it's a bit, you have to worry about too much stuff that you shouldn't have to worry about. Yeah, okay. So once this is done, the doors are like wide open for the instrument system, for MIDI support, and a bunch of other stuff as well that I haven't talked about. But I knew this day would come of having to rewrite the plugin system. I've known for a long time that I was going to have to do this at some point. The day is finally here, it seems. If this is actually what I want to start working on now. I have actually been working on it for 2 days, just doing another branch. I just created another branch here. So I've already started working on it. It feels like the right time to work on it. Okay, I seem to have run out of things to say.